So, welcome to my YouTube channel. So today I'm going to talk about one of the interesting topics in organic chemistry, alkanes. So even though this term is not used in our daily life, we use alkanes in our daily life. They are found in our gas cookers and even in our cars. The fuel, diesel, petrol, all of them belongs to alkanes. So first of all, I have mentioned some of the alkanes, and methane is the simplest alkane. And this is kind of like a pattern. Can be known as a homology series. So first of all, I would like to give you an idea about how these alkenes vary according to this homology series. So these are some of the most simplest alkenes, starting from methane. So then ethane, propane, butane, pentane, hexane, heptane, and etc. So I would like to show you this pattern which can be seen in this alkane. So here I have mentioned a general formula for alkane, which is only valid for acyclic compounds, by the way. So it is CnH2n plus 2. So CnH2n plus 2. So here, instead of this n, we're gonna add 1 because meth means 1. So instead of this n, we add 1, and here we multiply it by 2 and add 2. Then we got 4. So it's a pattern. So when it comes to eth, it means 2. So there we go, we add 2 here and multiply 2 by 2 and plus add 2, and then we get 6. So that's ethane. And propane, prop means 3, and we multiply 3 by 2 and add 2, so we get 8. That's propane. So as you see, there is a pattern. So I hope you got what it means. So this is the homology series. This can be known as a homologous series seen in this type of inorganic compounds, and it will be very important for you to have a good idea about what we're learning. So this is the general formula, and as I mentioned before, this is only valid for acyclic compounds because there are cyclic compounds of alkenes. So here I have mentioned some other groups. For that, I'll take this out like this. In alkenes, we use the suffix "-in" by the end. In alkenes, we use the suffix "-in". We use the suffix "-in" by the end. You can see it is a common term. It's ended with suffix "-in". So now I'm going to talk about something related with this. I'm going to talk about alkyl groups. So it's related with carbon alkanes. So here we have CH4. So if we remove one H atom from this CH4, we get CH3. Okay, so we give this a name, and that name is methyl. And see this too. So this is C2H6 ethane. So here we remove one of the H atoms, and we get C2H5, and we call that ethyl. Okay, and for propane, you can see C3H8. As usual, as in the previous ones, we remove one H atom and we get C3H7, and that's going to be propyl. So we call these the alkyl groups. And here also you can see something interesting. This ends with the suffix YL. And another important thing is this can only be seen in these first three. That means if we remove H atoms only from these three, we obtain these, and these are the only three alkyl groups which can be formed from these. So we can't obtain alkyl groups from these, right? I hope you get what I said. So I was talking about homology series in alkanes. It's kind of like a pattern, of course. Yes. So I would like to share some of the properties of alkanes. So if I simply draw a methane molecule, not molecule, I'm sorry, a compound, methane. So if I draw it, we go. This is the simplest alkane. Okay. So I would give you a statement like this. Alkanes consist of saturated carbons. Alkanes consist of saturated carbon atoms. Saturated means is fully occupied. It is fully occupied. And if you don't get the idea, I would further explain it with another concept, of course. So here, alkanes consist of saturated carbon atoms, and the other thing is these bonds in between CH. These bonds in between CH are identical. And if you have an idea about hybridization, you may know why these bonds become equal. So we're gonna talk about them. And another thing important about alkanes is alkanes consist of sp3 carbon. So I'm directly telling all the properties of alkanes. Okay, so we'll see. We'll see. So this is sp3, consists of sp3 carbon atoms. There we go. So I'm going to explain you all these facts, why it has become saturated and why it consists of a sp3 carbon atom, and those facts, and why the bond lengths are equal. I'm going to discuss about these properties which can be seen in alkanes under the topic I mentioned previously, hybridization. So that concept is important for us to understand this fact. So there we go. Okay, so this is just a part of hybridization, by the way. So if we consider about the electronic configuration of carbon atoms, so this is the valence shell, right? The valence shell consists of 2s2, 2p2. So if we draw the electrons, yes, this is the demonstration. So it consists of 2 electrons in s orbital and 2 electrons in p orbital. Okay, so this is how it looks like. So I have already drawn how it looks like according to the orbital diagrams, right? So this is how the electron arrangement of carbon can be seen when it's in the ground state. So if we go to the excited state, electrons, when they are excited, they go to their high energy levels. So due to that excitation, what if this electron moves into the empty p orbital? So this makes sense. Have you ever guessed why a carbon atom forms 4 bonds? There you go. Here. So first, when it was in the ground state, it was able to only form 1, 2 bonds, because these 2 are there, so we can't form any bonds. So when this electron goes to the excited state, there we go, these are singly occupied orbitals. Okay, so it has the ability to get bonded. So that's how we get these 4 bonds. And I was talking about how these get these equal bond lengths, and I was talking about sp3 carbon atom. I was talking about the sp3 carbon atom. So what can we think? So according to hybridization, this is the s orbital and this is a p orbital. I'll draw it once. Okay, so these are the p orbitals. So you can think, okay, if we consider about the bond length, we might get this for s and these long lengthy bonds for p orbitals. You just consider this is the demonstration for s orbital, so it's small, so that means the electron cloud, how the electron cloud has dispersed, it's a very small area, see. So the bond length should become small, but I told you it has become identical. The reason is hybridization, so I'm not going to talk about everything about hybridization here, but this is important for us to understand what sp3 means, because alkanes consist of sp3 carbon atoms, so we should know what it really means. So here what happens is the orbitals are going to get mixed and it's going to form something like this. So it's something like a combination of a s orbital and a p orbital. S orbital and a p orbital, and you can see both these are, my diagram is not identical according to my diagram, but you can see roughly they are identical. They are not different like this, right? So this is how the orbitals are going to form. This is how these orbitals are going to form. And the other important fact is this has 25% of s orbital character, 25% of s orbital character, and 75% of p orbital characters. Okay, so I hope now you understand how this and how these bonds are having identical lengths and why they are saturated and how we obtain this sp3 carbon atom. See, it is made up of one s orbital, I think I need this now, and 3 p orbitals. So it's okay for us to call this sp3 carbon atom. There we go. Yes. So that's how all these properties of alkanes, this is the basic theory regarding the properties I told you. So more than just by hearting them, I think it's better if we can have a clear idea about what this sp3 means, how these bonds having equal bond lengths, and what does it mean by saturated carbon atoms. So I hope now you may have an idea about the properties of alkenes. So as a last point, I would like to discuss about one of the important variations of this homologous series down like this. Okay, I'd like to discuss about that. So as you see, when we're going down through this homologous series, the number of carbon atoms increases. Okay, when the number of carbon atoms increase, what happens? The molecular weight increase. When the molecular weight increases, the dispersion forces increase. Due to the increment of the dispersion force, the melting point and the boiling point of these alkanes increase. As a result, the first few may remain as gases and liquids, and down we go, and when the number of carbon atoms increases, what happens? These become the solid ones. I mean, they can be obtained in solid states. So that's the very last point I want to share with you. So I hope you had an idea about alkanes. So see you in another video.